Good morning, everyone. Welcome to our Beowulf classes. We will start shortly. Meeting will be recorded, so please turn off your camera. Today, the co-host will be Wolfgang, and so I work at Beowulf as a supporting scientist for more than 2 years. But before that, I was a postdoc in NIH for a couple of years. So this experience gave me the opportunity to know what to the user of Beowulf want most, and also know like what as a staff, like what kind of information they need to troubleshooting, and what information they want most from the admin side. All right, we will start our class quickly. So this class is not a very basic. I assume most of the audience has some working experience with R. It could be RStudio or just running R script itself, or you could run your R on your laptop, or you had used R on other HPC servers. So the class will trying to help you to migrate smoothly to use the R module on Beowulf. By the way, all the red character is a hyperlink. So if you click it, it will lead you to our website or some reference it points to. A second thing is the class will try to help you to submit a batch R script for the cluster. And the third case will try to give some suggestions how to run the R code efficiently. Instead of a traditional lecture, we're going to go through several case studies. Okay, so we'll start the first case. Case one. Fry has an R job that needs a large memory than is available on his laptop. He plans to transfer his code and data to Beowulf to run the job. So what does he need to finish his job on Beowulf? You can speak or you can answer as a chat. It both works. Right. Let us make a summary. As some of you already mentioned, one thing Fry needs to pay attention to is does he has enough storage at the data directory? It could be our personal data directory, or it could be a shared directory for you and your lab members. The second thing is Fry need to pay attention to allocate it using a local scratch on the node. Besides that, Fry has to check which R version he was running on his laptop to choose the match the version on HPC. Other than that, the R package also could need to check like need to reinstall all the R package from a laptop to the HPC. And yeah, the last one, you just submit our job. Okay, the first thing is storage. So before Fry doing any analysis, the first thing he should plan is how many input he will have, output, and if there will be temporary file, he might be choose to use the LScratch in the next slides. As a default site, every user will have a home and data directory. Home is a 16 gigabit fixed size. However, the data directory will be 100 gigabit. And if you think the data will increase quickly, you better fill an online form to request to increase quote before you perform any analysis. A frequent question we got is like, I'm out of space when my job is running. Could you help us? However, it's depends on the timing. It might interrupt your jobs. In this case, Fry should plan ahead before start any data analysis on HPC. And again, there are several ways to transfer data. You can use the SCP, globals, all depends on how many files you transfer and the size of your file. Okay, so besides storage, the second thing Fry need to pay attention to is the local Scratch. This might be different from running R on your own laptop. On HPC, you can use the local Scratch, which will be allocated uniquely to your own job and clean up afterward. For example, Fry allocated 20 gigabits Scratch for the interactive session. You will use the general resources, pass the parameter to interactive, and if it's a batch, it will still work, or it's a swarm. And the reason to assign L Scratch is R will try to use temp dir to store the temporary file, and with enabled automatically pick up L Scratch. This number is a job ID if it's already assigned. Otherwise, R will use /temp directory, which is a shared directory for multiple users on that node. So it depends on how many user is using the node at the same time and how many program is running, is writing to temp. If it filled up, then your R job might fail. Normally, we suggest the L Scratch should be larger than 2 gigabit, and 5 to 20 is recommend. It's reasonable. And L Scratch directory could be cleaned up automatically, so you don't have to worry about that. So the third thing for I need to pay attention is the version of R. This might be a little bit different when you run R at your own computer. You only run the most recent version. However, on the cluster, there are multiple R version available. It's a 3-digit number, like the first 2 digits represent a major release, and the third one is a minor release. So for all the major release, they will share some library. However, each minor release actually, so each R version, even a minor release, will include many R packages. So you have to, and they were not this, so they were not very same. So if Fry needs a different version of package from multiple projects, it's better to use the PackRat, which is our environment management system, or use the RENV, which you will initiate to create a local environment and then create some snapshot with the version of R and the library you wanted. So on Fry's own laptop, he can check the R version with the session info again, this will be very helpful for troubleshooting. So besides the version of R, Fry also have to think about the version of our library. There are more than 1,700 R libraries installed on our current R module. And as a user, Fry can also install a package to his home directory. It will be home/R version, then library. If Fry hasn't created that directory before, he just need to run this command for the first time. And as I said, all the R major version will share the library. So the code would be make dir -p will create a library for example, using R 4.2. After Fry create this library, if you tap .libpath in R, it will print out the search library in order. So R by default will search your own library. If it find, for example, ggplot at here, it will use this version. And if it's not installed at this location, it will try to search these two libraries, and it will use the system version. So as a result, if you have ggplot2 installed both at home and system, your own version will always get used first. Just some note, like all the minor release of R will share the same library location. But however, there is some set library will be different. And the library for each version, so this command, you only need to write once if it falls 4.2. Well, if you want to use R 4.1, you have to create a different one. Okay, the next thing Fry needs to do is find which library was not installed on Beowulf yet, so he can reinstall. What he will do is, so sometimes Fry don't want to install his library at home anymore because his home directory is full. As I told you earlier, your home has 16 gigabytes storage, and they are not expansible. They're not able to extend. For most time, it's fine because most R package is small. However, occasionally, the library will include some big database like UCSC genome, and it could be easily fill up the home directory. So, for example, if Fry want to move the directory to data instead, he will create using bash or using run this script inside of R to create a directory. And next thing is you will change the environment to set up the RLibs user from home to data. And again, for example, you don't have to assign, this will pick up your library automatically. So it really depends on what what kind of library you are running, right? And again, for those large genome database library, they were already pre-installed on Beowulf. So for some users, this might be a useful information. Okay, the next thing Fry need to do is try to reinstall some R packages. Fry will first check the version of Bioconductor to make sure they were the same as the version on HPC. So the reason he has to check is So the bioconductor will have every 2 release for each R version. And currently for R4.2, the bioconductor version is 3.15. So that if Fry's bioconductor version is different, then if he's trying to, so he always have to check the R version, because you can't install a lower version of bioconductor on a higher version of R. Again, when your library is only available at a most recent version of bioconductor, to upgrade a bioconductor will also require to upgrade the match version of R. Okay, let's assume the case is much simple, like Fry's bioconductor is the same as a cluster version. Then the next thing Fry needs to do is get a list of installed package. You will call the built-in function of installed package and get all the name of the package. Then you save all this data to R data. Then Fry can transfer this R data to the cluster. Next thing is Fry will load the file and using set different to find the package that are not included in is not installed in the cluster. So the packages is loaded from Fry's laptop, and the second function will check all the available packages installed both on Fry's home and the data directory. Then Fry can run a bioconductor, to use BioC Manager to install the libraries that are liking. The reason we recommend to use BioC Manager is this command can install our library both from CRAN and bioconductor. So the difference is like for most R generic R library, they were available on CRAN. It could be biology related. It also could be statistical or physics library. However, the package from bioconductor will be much better documented. It's a higher, more biology focused. So there's one common problem user had is like, since the BioC Manager is installed as a system, like maintained and installed by staff, as a user, Fry will not be able to update the package. So if Fry run the command to install the package, it will install the one is not there. However, BioC Manager will always check update, and Fry should always choose no, since Fry will not have the right to the to the library location, which is quite common. Like, we don't want every user be able to update the packages that is shared use by all the users on the HPC. So again, if the package is available on bioconductor, you should always use the BioC Manager to install. But it's only one way of install our package, right? There's other way like dev tools, like remote. If the library is available on CRAN or bioconductor, Fry can email us. We would like to install the system-wise, so that Fry don't have to install his own location. However, for the package from GitHub, they might be more experimental, and they are it could include bugs. So if I want to use them, then it's better to install at his home directory and test there. Occasionally, you have to compile from the source code, then you can use rcmd install function. Okay, so there's when you're trying to install library, sometimes you just want to do a quick testing, right? Not break anything. I will recommend to use the Pacman. It's a R package manager tools. It conveniently it will wrap the package related function and then names them in a consistent way. For example, you don't need a quote when you run Pacman. So for example, if everything looks, you can load Pacman, then you can use ptemp to temporarily install a package. And if it looks good, you use pinstall to install the package. You don't need a quote. There are other useful Pacman functions, like you can use ploaded to check which library was loaded, punload to remove some package, and then this would be useful for troubleshooting. You install a new version and you don't want to restart your R. You can just unload it and then use library to call the package again. Pacman can also install package from GitHub. This is what pinstall gh do. And it can check the path of the library. Again, it's useful for troubleshooting. And it can check which library is available on CRAN. So the last thing I want to do is submit our job to the batch scheduler. As some of you might be familiar, Beowulf is using Slurm as a job manager. So all of the parameters here is Slurm uniquely. Here's the example: is if you submit our job, a batch job, you can define the job name, the number of CPU per task you're using, memory, running time, and you can also include the lscratch definition in the batch script. And you load your version of R, then you can change directory to the where rcode.r is located, and then submit the job with the batch. All right, so now we finished the first cases. We'll have 5 minutes for breaks, and if you have any questions, you're also welcome to let me know. I'll pause the recording here. All right, let's go to case 2. So Fred left NIH, and his colleague Lila inherits his code, but can't run his code successfully. The error is from Sarah package, so she writes to staff for help. So what information does Lila can provide for troubleshooting? Thank you for all the input. Yes, there are several things. It's basically like you you mentioned. You basically mentioned everything in here. It will be much helpful if Lila can provide error details, and if it's a batch job, provide job ID too. The R version is also important because we have multiple versions of R, right? So one thing Lila can do is just switch a different version to see if the error is repeatable. Besides, Lila could send the library, the R library version to, and occasionally update a newer version, updated version of that R package would solve the problem. The last thing is to check, is that the error is from your local library or it's a system one, like install at user local apps. So now Lila can check the version and the location. right? So since the package Lida had a problem is Seurat, the easy way to use the pack versions to check it's a built-in function in R. It will print the version of Seurat. And then to print the path of the Seurat, you have to load the library first. However, the other ways you can use the pacman, which you only need to load the library of pacman, and then you don't have to load the Seurat. It can already check the path for you. So Lida found that it's her Seurat library is loaded and the version is 4.0.1. The next thing Lida will do is to switch to use the system version first to see if she can repeat the error she was having. In here, you just use the pacman to unload the Seurat and then reload the Seurat again. But this time you give the library location to the system version. So it's possible the error still persists. You probably get familiar, like not our package is perfect. And if the same thing, you're welcome to write to us. We can help to try to fix the bug or at least point the bug to the author or fill a bug report at GitHub. But if the error is gone, so it's probably time to remove the local version. So in this case, so some of the package was installed and maintained by HPC staff is because we compiled of the source code differently. For example, the Seurat installed in the system can run much faster than the local version. So that's why we always suggest to check if the library is available first, and then use your local version if necessary. I mean, again, it's also because Seurat is a high frequently used library. So the next thing Lida would want to do is just remove her local install package. So there's multiple ways you can do the same thing. First is you can remove package. This is a built-in function in R, but you have to add a quote. I use pacman, you just need to load pacman and you can delete a package without quote. Or you can go to your bash and just remove the whole binary library in your RLib user location. So here the example is assume your R library is by default at home. Of course, you can switch it. And again, you want to make sure you only remove the version like you were running. So the next thing Lida want to test is you want to test the interact. I guess a lot of us already mentioned this already, like how to run R besides the command line, like in interactive ways. So there is RStudio installed on Beowulf. It's a graphic applications, and it might easy to write some markdown file. You did about some Shining Web, I use the Qualto. However, for graphic applications, we suggest using NoMachine. And here's the example. So if you want to see the detail, you can follow this link. We'll have step-by-step detail to how to run RStudio. Here, just the command you will going to use. And I will always suggest to load your version for R so that RStudio can pick up the R version quickly. One thing I need to mention is when you exit NoMachine, please be careful because to click the window, close the window doesn't mean you turn off the NoMachine session. It's better to exit or log out to make sure you close the NoMachine session. Otherwise, there were too many people want to using no machine, and then sometimes will run out of license. But because like Lila might didn't know, like she didn't exit no machine. She thought she is. All right, so this is a quick cases. Basically, we just cover the library install and running R interactively. And a lot of people already asked RStudio. Guess we can start a quick break, or do you want to skip? I can change the break time very short. Any question I should address? Wolfgang, how busy is the chat?
I think I've mostly kept up, but if I've missed something you asked, please don't be shy to repost it. There's been a decent amount of traffic.
All right. Yeah, thank you so much.
I had another question. First question was, why did you remove the package locally? Could you explain that one more time?
Okay.
In this case.
So that's only happens if like go back a little bit. So Lila was checking, has some error to when Lila run the program, right? It has some error, and then Lila checking which version of Seret was using, and then the path showing out the error is caused by Seret from Lila's home directory. So Lila was a switch to a system version. So here you can see a location from user local app. It's installed and maintained by HPC staff. That means, so sometimes the R package have bugs, and occasionally our staff will patch the bug to make it run on HPC. And sometimes when you install our library, it can interrupt something or have conflict. So it's not a complete install. So you remove, so here just remove local package. And occasionally you just remove it to reinstall can solve the problem. So you don't have always to remove package. However, Seret is special cases because this package is compiled differently on a cluster than the one you just download from GitHub.
Okay, so it's not enough to just move to the system. You also have to remove the local one sometimes to get it to work.
So in this case, sorry, can I repeat your question first? So you're asking if the bugs exist in both local library and system library. In that case, it's better you email us because only staff has a permission to delete the system version, right? And the example I showed here is the system version work. In that case, Lila will try to delete her local library. Did I get your question?
I guess conceptually, why do we have to remove the local library when we're doing something on the system? So I guess I'm just still understanding the back and forth here. So like, why would I do number 2 on this slide if the error is gone?
Okay. Yeah, good point. So it's from a very earlier slides. If you don't mind, I have to go back a little bit. So the way our work is, it has a search all the available library in the past. And your home library is always the top one. The system library is later. So if you don't remove it every time, I mean, if you don't give the local, if you don't assign the library path, then it will by default always use that one. Of course, you can just change your code like every time just to load it from system, but like if you always put this one, then it will work. It's just a lot of work.
So you mean the local library is mean the library in your home, and then the system library is just the global one, right? Everyone.
Correct. Yeah.
Okay.
But I think you can set the library path to point to a certain location. And if in your script you load the library throughout with this location, it's saved in your script, and each time it will automatically load from this location.
Yeah, I mean, you can set up, but sometimes like you can change a lot at your path. But the concern is that the default web would be easier for us to troubleshooting. I mean, you can do it as long as you know what you're doing. That's my saying. And we welcome other suggestions if you have better idea. Okay. All right. Are we good? Is that time to keep going? All right. So we come to case 3. Will more CPUs and more memory will save the running time? Case 3 is Amy has a deadline coming soon. So she wondered if allocating more CPU and memory will speed up her job. Well, yeah, I shouldn't put the answer there. Any volunteer?
I think sometimes it can help,
Yeah.
but not all the time. I think it depends on like the threads or something, how many threads you need.
Right.
Yeah.
Oh, so yeah, keep going.
Oh, it may depend on how much memory the script is using, like if it's running out of memory, or if it needs more, if it could use more memory to go faster, then memory would help, otherwise not.
Yeah, good point. Right. So as you guys guess, it really depends. So the base R is a single thread. That means regardless how many cores you're allocated, the R can only use one CPU, unless you tell the code to use more than one CPU. And for the memory, if you allocate more than the one you needed, it will not really speed up your program. In this case, there were 8 CPU was allocated and 10 gigabit memory was allocated. However, it's only got one CPU got used. All right, so we'll suggest when you run the job, always checking our dashboard. Here is an example, is a command line graphic, and you can also use the command line. So when to increase memory, so one of our volunteer already speed up. If your job gets killed, so Amy can check the error message. If you see something said killed, it's out of memory kill. If Amy was running RStudio, it's already very obvious because the session will just gone and the window disappear. If Amy check the dashboard, you will see a yellow explanation point. That's a memory over. Or if Amy using the dashboard command line, you can also see the error at the very end. Somehow the slides show on Chrome just doesn't allow me to. All right, okay. So how does Amy know if it's worth to try parallel computing? or increase memory. So if her job is running for a very long time, like 9 days, then maybe yes. So everything is a trade-off, right? If you spend a week to figure out how to run your code parallelly and your code can only finish in 1 hour, it doesn't worth it. The second thing is sometimes our code will be read in C++. In that case, just save your time. Do not try to make it faster. And the other chance is one part of a code consume most of the time, then you might want to look back to see if that part of code can be rewritten, could be make it faster. And there are several ways she can use to identify the bottleneck program. First is using system time. This is a built-in function. You can estimate, if you have multiple functions, you use the system time to count the time consumed for each function. And then there's other ways like R profile, and which will run a performance analysis of your code, and then a summary R profile will summarize to count each step, the time percentage they spend. So for all these two functions, you can just click, and they were much complicated. Again, you have to estimate the time you're spending on it and the performance you want to improve. All right, so if is there any way Amy can know like her code can be run in parallel? There were different level of parallelization. For example, the multiprocessing, as you guys mentioned before, like using Swarm, that's a multiprocessing. And then there's a multi-thread. It's normally a built-in function. If her job can be split to multiple independent process, like if she's running a program to process data for each chromosome, they should be independent, right? Then that will be multiprocessing parallel. However, sometimes her code might be already support multi-thread parallel. And in that case, you have to let the computer know that you are going to use the multi-threading. The other thing is Amy can also check if there is any function like L applying or S applying. And also a good point is if you see a full loop, you might think there might be something, like when you see a loop, there's always something you can do. I mean, again, if the loop is very long, right? If you only have like 3 samples, you don't have to run a full loop. And it doesn't worth the time to try to figure out to parallel or not, unless you want to learn something, of course. First example is for the multiprocessing parallel. We also call it pleasingly parallel or awkward parallel. For I think for most of the cases, there's some noise in here. Let me see if you. All right, I think it's better now. Thank you for people who mute yourself. So Amy can submit the Swarm job if each of those jobs were independent to each other, right? You can just, this is an example. I think one of us already asked question how to submit. This is a template, like each line represent one sub job. And in this case, when you submit with Swarm, it will generate 3 sub jobs for you. And each one will use the resource you allocated. If you give the memory and CPUs, it will each subjob will pick that up too. So besides, so when Amy submits this Swarm job, some work, but some Swarm job will fail. So which happens? So what do you think it's a cause that? Well, yeah, there's some reason in here. It's a little bit specific, but actually, I think what Amy really should do just to rerun her job. That's another thing you want to do, right? It could be randomly. If you can repeat it, then it's time to figure out why. And here's some hardware difference you might, like Amy should pay attention to is we have some FIS6 nodes. They have more than 128 CPUs. And for our large memory node, have even more CPUs available. You can check use the free and on the command line. So our package will detect all cars on a node if they were using parallel detect car. So parallel is our built-in function. So if it's very hard to change. So it will always report the number of detected cars. If Amy didn't specifically assign the number of CPUs, the script might use all the CPUs. However, R cannot build a connection with more than 125 workers. So so at least 128, because it will definitely fail. After 125, it's 3 of those 3 of those connection is reserved for R. That's why the error will be said all connections are in use. If you see that error, okay, the solution is if the code has a parallel detector code, just replace that with parallelly available code. This is parallelly is a much newer function, and it can, if you allocate the number, it detects the allocated CPU, and it will not report the whole number of CPU. Well, the other chance is if you realize in your job you allocate more than 125 CPU, it will fail. So it's better to use the fewer CPUs instead. However, sometimes it's not that clear. Then it really depends on your code. And again, if you see some error, like you can repeat after repeatedly, and it's not random, please, you're welcome to email us to figure out why. All right, so that's for the multiprocessing parallel. So what about for multi-thread? The R installed on Beowulf is using the MKL libraries. This might be different from your local, your R installed on your laptop or the R you use on other cluster. Again, you can get that information from session info. Some functions can use a multiple thread. So, but Amy need to find out if allocating more CPUs can make it faster. The first thing is you will try to run the program under multiple thread. So this is testing, right? Like in theory, you think it might be, but you never know until you test. And then Amy used the OMP number thread to set up to equal to the allocated CPU and then run the script. However, when she checked the result on the dashboard, she found that she was using 32 CPU instead of 4. So this is quite common on cluster. notice as we call it overloading. Like in dashboard, you only allocate 1 or 2 CPU and you're running a lot. CPU, you actually use more. Well, we don't recommend overloading. I mean, in this case, Amy didn't know her code is overloading too, because it's actually can slow your job dramatically. And by default, right, the OMP number thread was setting to 1. This is a setup in our module because we want to prevent overloading. And then she reran the job. In this case, she was only using 1 CPUs. So it's still not 4. So that's basically because her code itself can't use it doesn't, if your code didn't have the call the multiple thread function, then allocate more CPUs will not speed up. However, we normally suggest you don't touch it unless you know what you're doing. I mean, again, it's just want to prevent overloading. Okay, so Amy want to modify the code to use more CPU, right? And in this case, there is some function like loppline, so she can just load the parallel library. And next is detect the number of CPU by using parallelly available core. So this number will vary depend on how much what's the number you are passing to your job, and then you can use this. You just pass the number of CPU to loppline. In this case, we in the testing case, you're testing with 12 CPUs. So here is just using, if your code has loppline, like you can easily replace with loppline and pass a number of CPUs in here. It's a much easier like to speed up if you have a lot of sample in there. Again, well, if your loppline is a small loop, like only have 3 or like 10 function variables, then don't bother. It probably take more time to start the parallelization. Similarly, if you have loppline, you can also replace with loppline too. So next will be performance comparison. You will assume after you assign 12 CPUs, you will speed up too. You will save like 12 times of time, but the reality is normally not. In this case, compared to the 1 CPU, we use 12 workers. However, the time for the loppline is 38 seconds, and it only reduced like 1/3 of the time. In this case, the efficiency you can calculate is 3 divided by 12 is only 25%. So this might be different than your expectation, but it's quite common in the parallel job. So for job when job trying to use multiple CPUs, it has to spend more time to start. So it depends on the sample size, and if, for example, if you reduce the number of n to a much small number, you barely see the difference. And again, in these cases, the efficiency is quite lower. So we normally will suggest a efficiency like a 70 to 80%. So summary is more CPU do not always mean run the code more efficiently. For example, if you have a loop like 22 chromosome, but you submit a job to 40 CPU, then it doesn't make sense. It will not really use the resource smartly. So for the same reason, we normally recommend to run benchmark testing, especially for parallel job. You can find the code of these cases in our documentation. And then you compare, here is show the performance comparison from 2 CPU to 32. And you can see if we use 70% as a efficiency cutoff, the job that shouldn't be submitted with more than 6 CPUs. I mean, you can still a little bit speed up, but basically after 32 CPU, it doesn't make much differences. Just one more note is the MCL offline and MCS offline can only use multiple core on one node. So most of the slides I'm showing here is just for parallel job on one node. I didn't include multiple nodes. It will be much complex. Like Snow can do that. But it really depends your request. Think like if your code can't use other than 32 CPUs, then if you allocate more nodes, that means you have much, like the number of CPU requests could be enormous, but it doesn't mean your code can be that much efficiency. All right, so that's the end of the third case. Do you have any question?
So what makes MC apply faster? Like what's going on in the background?
So MC applying, it's basically just run your, so your outline will just apply a function to each of your variable, right? So MC will distribute it. Let me give a case here. For example, you run our appline from 1 to n, you just run a function, just calculate the norm number and then 1 by 1, right? Sequentially. MC appline will still run this one, but it will distribute it to, it will still apply the function to each of the number, but distribute on 12 CPUs, so 12 cores. However, at the end, you still have to put all the data together back. That's why there is some time to start a parallel and at the finish when you merge the thing together. That's why, for the reason, like if the number is so small, when you distribute the calculation to each worker, will take much longer time than running them. So this is for the multi-threading parallel, right? But for those multi-processing, for the Swarm, the job you can submit Swarm, that normally can guarantee faster because it finish, it doesn't have the time to distribute it and doesn't, at the end of calculation, you don't need to merge the data. So at the back end, do MC is using the parallel package. So again, if you're interested, you can test this function, but just try to overloading that one. You will see the speed probably even longer than the sequential one. So that's why always checking the dashboard to make sure the right number of CPU is got used. Oh, sorry. Yeah, I was pressing the Well-Wolf logo and go to our website.
Hi, I have a question about this parallel to run R code. Does Bell-Wolf support RMPI? So here previously we used RMPI more frequently here, and I think it's it's easier. And I saw you have a limitation for the parallel function. It cannot use the multiple nodes, as you mentioned in a later slide.
So yeah, MCL apply and MCS
Yeah.
apply do not work
Okay.
on multiple nodes.
Yeah, but for
It's a-
RMPI, yeah, it
Yeah,
works. And
right.
yeah, I'm
Correct.
wondering if Valve support RMPI using RMPI is a package for parallel
Yeah.
computing. And I guess there is another package, something like RSLUM. Yeah, it's also kind of wrapper to run the code, R code parallel. Yeah.
Yeah. I heard about RSLUM, but I haven't tested. Some of our staff might have more experience on that. RMPI is supported on Valve, but multiple nodes calculation, you need a lot of homework. And maybe I think Wolfgang have more working experience on RMPI.
Yeah, so just to chime in, yes, we have our MPI set up, and we have some examples for our MPI on our webpage. We also do have our Slurm. They're intended for different things, right? The R Slurm is basically for really pleasingly parallel things that can run truly independently. With RMPI, you can actually run tightly coupled calculations if you want to do it in the traditional MPI way. You can also use RMPI more like a backend for, PAR4, basically for parallel for loops and things like that. But before you're thinking RMPI, do some scaling on a single node, because, like she was saying, a lot of times our code doesn't scale particularly efficiently, and we really want everybody to run parallel code in the efficiency range of 70 to 80%. So if you do, start using RMPI, please do some careful benchmarking, basically.
Okay.
But it's installed and there's examples on our webpage.
I see. Thank you.
Yeah, thank you for answer that. Okay, let's see. So thank you for everyone's time. You can always check in our up-to-date R documentation. And here it includes a lot of things like I mentioned today. And you can find some RSwarm and RMPI job examples. Okay. Besides, if you have any question, you are welcome to email us. We have a great support team. I need to also mention we have a walk-in virtual conversation every month. I think the next one will be next Wednesday from 1 to 3 afternoon. So last part will be some working through case study. If you want to test out, but given our business or our cluster, if you haven't have a job open, you probably need more time. Probably your job will curate for a while, but you don't have to. It's just one option. If you want to hand on, you can try to do that. So there's 2 case study. I mean, it depends on. Okay, I will go through it. Then I'll give you some time to think, and then maybe we can troubleshooting together. And if you have some question, you're also welcome to ask. So the case study 4 is like a vendor has some code and it's already used multiple CPU, right? It will use do parallel and load the do MC, and then you register like make a cluster with available cars. So the function is trying to calculate a max eigenvector of a matrix. And then it will try to call the function from 400 to 500 and call this function. And Bender has a job script like load the R and then run R with R Vanilla and submit with this script. So there's a lot of things can be done, and there's something we don't recommend to use. It's supposed to be a case study, so just speak up if you think there's some way you can change the code. And I will give you 1 minute, maybe 2. I mean, you can work on yourself, or if you have some idea, you can talk in the chat or. Does anyone spot some problem here? Oh yeah, someone said for loop, good catch. Right, so if there's for loop, you can change that to for each and do par. Yeah, check for available cars. Right, so that will be parallelly available cars. Yeah, that's a good one. How about special job and how do you submit? I think does this counting down make you nervous? Right, that's a good one. The job is missing out scratch allocation. I can pause it. Yeah, but the red color might make you more nervous. All right. Right. Yeah, that's a Susan catch it. Y'all batch the parameter should be before the test. Okay, so here's just one solution. You have multiple ways to do our job, right? So as you catch up, the parallel detector car should be replaced by parallelly available car. Otherwise, you will detect all the physical CPU there, and it will cause overloading. And there's for loop could be changed to for each and do parallel. In this case, it can, well, in this example, it will do faster, but again, it depends on the on your code. Sometimes it's not. Sorry, I pressed the wrong button. And for the batch job, so this is probably a hard one. Is the example is using R-Vanilla, but we don't recommend that. So you can use R. It's better to use the R-no reserve to not save the current environment, because Vanilla will start R with a very fresh environment, which do not load our current setting, like OMP number thread and some other thing. So we instead, you can use R script, or you use R no reserve. And the submit job, you already catch the L scratch, and it should be parameter should be before your batch job. And here's also some catch, like the memory should have a G. For will fail like this memory, and do not use n task. That's for MPI job. You want to use the CPU per task instead. All right. Okay.
Hi.
Yeah.
I
Go
have a
ahead.
question about the batch job. So there's no command line to indicate whether the tests are under, maybe we don't know the location. So when we run this code, maybe I'm not sure whether it works.
Right. By default, I assume this code you have to save to your current location. So when you submit the job, so there was two ways you can submit the job, right? You CD to the directory if it's a file test R, then submit there. Then you don't have to give the pass. The second way is you want to submit your job at anywhere. So then you should add a CD.
Okay, got it.
Yeah. Oh, that's a good check. I should add that. Good point. Okay, so you want to leave demo of this one? Let's go to another case. Then, I mean, I saw this quite obvious. You can just compare the difference between. We can discuss that later if time permit. The second walkthrough cases. So this is the last slide. Is if Bender's job is R script to run something and then out, how does Bender modify this code to be able to run on a cluster? I mean, I have a hint there. So it's a typical example for multiple processing R jobs. And the problem here is the vendor at first has to write like dozens of R code. And what you need to do here, just one example is, oh, okay, this time just came out not the right time. However, one simple is you can simplify that to R script, to one R script, and then pass the variable later, and then write the output. And in this case, it can reduce the number of script you're writing, and you can read the input from environment and then submit this to using a Swarm job submission. Yeah, someone already answered that on the chat. Great, good catch. Right, yeah, okay. I guess I can stop recording now.